Today we will start with your scanning. The tools that were part of your information gathering, we will cover them in your malware and social engineering section. So in information gathering, we got to know that how we can collect information, what type of information we can collect over our target, be it a network or a host or an organization. In scanning, our goal is to scan your host. Okay, it means to get basic information about your target host. When I say basic information, it means whether your target is active or not, your target is live or not in the network. Because if, let's say, I'm attacking your machine and your machine is offline, okay, it's not in any network. So I cannot do a attack. I have to think of a physical attack. So, first thing is to discover whether your target is up or not. Okay, whether I can connect to your target or not. This is the first thing I will check. Once I get to know the target is up, then second thing is to check the open ports. Find open ports at your target because through one of these ports only I will be getting into that target. Then third step and final step of your scanning is check what all services are running on the open ports. Check what all services are running on your open ports. These are the three things we will do in your scanning phase. Now, first thing, very common thing, your ping. Simply ping the IP and see whether you're getting a reply or not. Then you guys said IP scanner. Okay. Now we can add your trace route or your traceroute to check how my request is traveling from my system and how it is reaching your target system. How many hops are there in between? Okay. With the help of these two, traceroute is for Linux, traceroute is for Windows. Okay, I can do that thing. So let's try. So ping works both on your Windows also, on your Linux also. So if I open my CMD, let's say on my Windows machine, if I let's say ping google.com, I'm getting a reply. 4 packets sent, 4 packet received, 0 lost. Okay, it means google.com is live. And if I type google.com on the browser, I will connect to the Google page. Then we have traceroute. Okay, so if I try to find the route, traceroute google.com, it will tell me how my request is reaching your Google, how many hops are there in between till my request reaches your Google server. This is the IP of your Google server. Okay, so this is also a good way to find. Now, this particular thing is very useful for me as a attacker because I'm seeing some public IPs over here. Okay, some broadcast IPs over here. Okay, so if I'm able to get access to these IPs, I can make changes in the request from my machine, from this Windows machine till your Google machine. Okay, that thing can be happen. Now here you can see one more thing. By default, when I was pinging google.com, I was sending 32 bytes of data. By default, when I was pinging your google.com, it was sending 32 bytes of data. And here you also have a TTL value. What is a TTL value? Time to live. What does it say? What does it mean? Maximum hops. Okay. Time to live basically means it is telling you that how much maximum hops your packet can travel before it expires. So sometimes by looking at the TTL value also, you can try to guess the operating system of your target. If I show you one website, they have changed the configuration of this website. So you can see you are seeing HTML tags. It means someone has changed the code of this particular website because of which we are not able to see a proper table. TD means table. So all the columns that you are seeing, these are part of a table which we are not able to see properly. So let's Google it. Okay, see, here are some basic TTL values. 64 for Linux, Mac operating systems, 128 for Windows, 225 for network devices like your router. Do they have a proper table? No, they don't have a table. Now here you can see initial TTL values for different devices OS with respect to the versions on what particular protocol. Okay. So here if we go for Linux, mostly for 2.0.x kernels at ICMP, it will be 64. For 2.4 kernel ICMP, it will be 255. For Red Hat 9 Linux, 64. If you look at the Windows, for Windows 95, 98, 32, 98, 98 SE, ICMP is 128. We are looking for Windows 10, Server 2008, Windows 7. They will have 128 TTL value. So sometimes just by looking at the TTL values, you can try to guess what is the OS at your target. Okay, what device you have at your target. Now same thing if I open my VMware and through my Linux, if I try a ping command, you will see that we are able to send a ping request to your Google. So let's start our Linux. How can you find your own system IP? What is the command of your CMD to find your own IP? To find your network configurations? ipconfig. For your Windows, fconfig for your Linux. See, if I write ipconfig, I'm getting my Windows IP configuration. Okay, here you can see this is my current IPv4 address. I'm connected to Wi-Fi 2. This is my current IPv4 address. For my Wi-Fi 1, it is dot 1.42. One more thing you will see here, you are not seeing any MAC address. Okay, so if I write ipconfig hyphen all, okay, hyphen all, what it will do, it will give you all the details. So if we go to your Wi-Fi 2, here you can see in Wi-Fi 1, I'm getting my MAC address also, physical address. For Wi-Fi 2, physical address. For my IP, what was the lease and when it will expire. Okay, so with ipconfig space hyphen all, I'm getting a more detailed info as compared to your IP config. Your lab section, there is one Metasploitable machine in your task list. Process is very similar to your Kali only. Unzip it and open the VMware file in the workstation and click on I copied. Docker service is running ETH0. I'm getting the IP. Okay. I have the address also. Okay. So here we don't need to type hyphen all. Now here if I try to ping your Google, 5 packets transmitted, 5 received, 0 packet loss. If you look at the TTL value, we are seeing 128. Why 128? Because in my Windows, when I was doing your ping command, it was 113. But here I'm getting 128. Why is that? How the virtual machine network is designed? This is my router. Router is connected to my laptop that has Windows. Okay. So my machine will have some broadcast address. Okay. Then network ID and your gateway. Okay. Then inside this Windows, we have your VMware workstation. So here for this particular VMware network also, we will have one broadcast IP, network, and your gateway. Now we all know by default dot 0, dot 1, and dot 255 is reserved. Okay. So for my Windows, 255 will be broadcast, dot 0 your network, and gateway your dot 1. Now these three are already reserved. So for VMware, since 255 is already reserved, 254 will be your broadcast. Network dot 0 is already reserved. So my dot 1, my gateway of Windows will be acting as a network IP of my VMware, and dot 2 will be gateway of VMware. So when I'm making a request to VMware, request is going through Windows, and then through Windows it is going to my router. So that is why here you are seeing detail value of 128. Now next thing here is you are seeing something by default I'm sending 32 bytes of data. If I check this thing in my Bioshock, okay, that what is the size of the frame that is going out of my network when I make a ping request to your Google. By default here in this terminal I'm saying 32 bytes of data. I can change this also, right? With the help of -L option, ping -L. Let's say I want to send 64 bytes. 64 and google.com. Now I'm sending 64 bytes of data. One thing is we have to see, is there any limit for the number of bytes I'm sending to the target? For example, what if I want to send 1000 bytes of data? Let's try that thing. So ping -L, let's say 1000, google.com. I'm getting a reply for that also. What if I want to send 10,000? Now here you can see I got a request timeout. I started getting a request timeout. 2 packets sent, zero received. It means there is a limit at the target. Okay. That maybe 1500 bytes of data is the maximum. Okay. Maybe 2000 is the limit just to prevent DOS attacks. Okay. Just to prevent people consuming your network bandwidth. This is a very simple reason. Okay. I don't want that people making very large requests on my network so that they start consuming my network bandwidth because it will affect other users who are trying to access my service at the same time. And the example which you are giving, that thing is called as ping of death, where you are sending multiple pin requests from multiple machines to a host just to try to consume their bandwidth. Okay, that attack is called as ping of death. Again, a very basic question. Right now, here we are seeing by default we are sending 32 bytes of data. If same thing, if I try to analyze it in the Wireshark, okay, I'm connected to Wi-Fi 2. Ping works on ICMP protocol, right? So I will apply the filter ICMP. I want to catch the traffic of ICMP and I will ping your Google, ping google.com. Now here you can see we got a request timeout when we were pinging Google. First reply was in 127 ms, second was in 52 ms. Detail value also changed every time. Okay, let me close one connection, another network. Let's see again. See, Zoom is not connected to Wi-Fi 2. It is not my network. Because if Zoom was connected, I would have seen UDMP protocol. Let's change to Wi-Fi 1. Let's capture the packet from Wi-Fi 1. Yep. Okay, here you can see a lot of UDP packets. So these are all for your Zoom. Here you can see your ICMP packet that has been captured when I made a ping request to your google.com. Now here you can see the length is 74, frame length is 74 bytes. So what is the difference? What is the difference of this 42 bytes? Here I have 32 bytes. Here the length is 74 bytes. So what is the difference of the 42 bytes that we are seeing over here? So if I draw a frame size, okay, a complete frame, that what all things will be included in that particular frame. This is your complete frame. Size is 74 bytes. So the 32 bytes which you are seeing here, this is your data variable for your ICMP protocol. This is of size 32 bytes by default. Okay. Then you will have ICMP header, which will be of size 8 bytes. Then you will have your IP header, which will be of size 20 bytes. And at last, you will have your MAC header, which will be of size 14. Okay, so these three things will be of 42. 20 plus 8, 28 plus 14, 42 bytes. Okay, so the 32 bytes which we are seeing over here, this is your ICMP data variable. So when I change the size of this particular variable, you will see the change in the length of the frame also. So if I try this thing, ping hyphen L, let's change it to 40. Okay, let's increase by 6. Okay, so let's change it to 38. Now here you can see the frame length has changed to 80 because I have changed the data variable. Okay, again a very basic info that we should be aware of. Right now we have seen that your ping was working on ICMP. Okay, your traceroute also works on ICMP. Your trace route, it will work on UDP. Okay, so what if target has blocked the ICMP protocol? Okay, for example, let's say we visit a website. Okay, this is the website. Here you can see as soon as I entered the domain, a web page was loading. It means the IP is live on the internet. I can access the IP on the web. But if I try to ping it, ping elm.sa, I'm getting a request timeout. 2 sent, 0 received, 100%. If I try this thing with your Linux also, ping elm.sa. Here you can see we are not getting any reply. Let's wait for that. So how you will find whether your target is live or not? I can see that I can open the website. Okay, website is live. But when I'm doing the ping, it was giving me a timeout. Okay, it means ICMP protocol has been blocked. Anyone who's trying to make a request through ICMP, the request is getting dropped. That is why we are not getting any reply. So here, what we have to do, we have to use some tools or some utilities which can help us craft the packet. Okay. We all know about TCP flags, right? So if I talk about TCP flags, okay, now these flags are used during your TCP connections. So six common TCP flags that we have. First is syn, synchronous. Second, ACK, acknowledgement. Third, your fin. To finish. Fourth, we have push, to push a particular request. Then we can add your urgent, URG. And last, the sixth one, your reset. Reset. okay, RST. These are the 6 common TCP flags that you will see during your TCP connections between two machines. Now, the second flag, acknowledge, we have. It means whenever we send the acknowledge flag over a TCP connection, the target should acknowledge it. Be it even if the target is having firewall. If I'm sending a acknowledgement flag, it means it should be able to pass through your firewall. And I will get a reply from the target for my acknowledgement flag. So here what I can do, since I'm not able to ping your elm.sa website, so I can craft a acknowledgement packet and send it to the target. So as soon as the target receive this packet, what they will do, they will reply to it. Okay, they will acknowledge it. So this thing I will be doing with the utility called hping 3. hping 3. This is a packet crafting utility which is present in your Linux. So with the help of this, what I can do, I can craft my own packet. Let's close this thing. Here you can see 236 transmitted, 0 received. hping 3 hyphen. Okay, these are the arguments that are present with your hping 3. Okay, these are the arguments I can use with your hping 3 utility. So here you will see one hyphen a argument. What it will do, it will set your acknowledgement flag in your packet. Okay, it will set a acknowledgement flag. And as I told you, acknowledge acknowledgement flag will always get a reply. So if I write hping 3 hyphen a for acknowledgement flag and send it to your target elm.sa. Operation not permitted. Okay, let's change the permissions. Sudo su kali, let's run it as a root. hping 3 hyphen a elm.sa. 4 packets transmitted, 4 received, 0 packet lost. Okay, so sometimes when ping and traceroutes are not working, ICMP is not working at the target, what we can do with the help of hping 3, we can send the acknowledgement flag and see whether the target is replying to that or not. And here you can see with the help of this particular utility, I got to know that your target elm.sa is live because I'm getting a reply from them. And their IP is 185.131.97. Now, how you will find what all IPs are live in your network? Any utility that you know of, any command or any tool that you know of to check what all IPs are live in your network. For example, here you can see on my VMware network, I have one Kali machine running. Other than that, if I want to check whether any other IP is live or not for my VMware network, do you know any tool, utility, or any command that can help me with that? Angry IP scanner, it is for Windows only. Okay. But right now I'm into my Linux. So I cannot use this particular tool. This is a Windows tool. And with the help of this, you can also find open ports. Address resolution. protocol. Now this thing will only work in your internal network. ARP will only work in your internal network. So let's say I want to find that what all IPs are live in my VMware network. Okay. So IP of my Linux is 192.168.17.130. Okay. So what I will do, I will run the ARP scan in the complete subnet and check other than 130 what all IPs are allocated. So I can write something like ARP-scan and then my complete subnet. 0/24, all the IPs covered in this. So if I execute this thing, other than 130, 130 is of my Linux. I'm getting .1, .2, .254. And as I said you earlier, these three are again reserved IP. .54 is your broadcast. .2 gateway. .1 network. And here you can see also in my VMware only one machine is running. That is your Kali. And IP of that is 130. So other than 130, these three IPs are live in this particular network. And how we got to know that? With the help of ARP-scan. Okay, so now since I know these three IPs will always be reserved, if one more machine is active, let's say I have one more machine present on my VMware network. So when I will run the ARP scan, it will give me the IP of that particular machine. Let's say the IP is .140. If I have one more machine, so it will give me two IPs. Let's say 144 and let's say 132. Okay, so with the help of this, I can find how many machines are live in my network. Okay, so those who have installed your Metasploitable 2, okay, the Metasploitable machine, simply open the machine, and once you get the login page, okay, which will require username and password, come to your Kali Linux, run this ARP command, and see what is the IP of your Metasploitable machine. Check this thing quickly. And remember, everyone will have different network. Okay, so don't just write 192.168.1.7. This is for my machine. Open your Linux IP, and through that, scan the complete network. For example, if your IP is x.y.z.w, so what you will do? You will run ARP scan x.y.z.0/. Okay, and quickly find me the Metasploitable IP. Just like your Linux, download the zip file, unzip it, open the VMware configuration file in your workstation. Okay, let me install just like you guys on my machine. Let's see whether I have it or not. Yeah, I already have it. So let me install it one more time just to showcase you guys how to do that. Okay, so here you can see this is the file, the zip file. I will unzip it. Okay, so this is the folder. What I have to do, I have to open this virtual machine configuration file in your VMware. Open with workstation. Here you can see I got the machine, power on the virtual machine. I'm getting option. I will simply click on I copied it and my machine is ready. Okay, it will take a minute to install all the settings. You can see it is starting so many services. It means so many ports are open on this machine. So I got the login page. If I go to VMware, if I run the ARP scan again, I'm getting one additional IP, 135. So 135 is the IP of my Metasploitable machine.